Okay, so in this video, I'm going to go through this example right here that we just talked about in notes and talk about what the process is going to be for us moving forward. So the first thing that I have here, let me turn this for you guys here. The first thing that I have here is a z-score of less than or equal to negative 2.25. So somebody calculated the z-score and we got negative 2.25. So my first step, and I kind of talk about this below, but my first step is always going to be to draw the curve. Before I start doing anything else, I'm going to draw this curve. So we draw the curve, and this is where I would have my mean at 0. And this value is, like I said, negative 2.25 standard deviations below the mean. So we draw it out with 3 standard deviations. You do your best to get all 3 on there, with the third one being very far out on the tail. And these are about as close as possible to being the same distance. So this is like 1 standard deviation away. This is 2. This is 3. So 2.25 would be like somewhere in here, like further than 2, closer to 3, but not as close as 2.5. Okay, so I'm going to put here z is equal to negative 2.25. The next thing that we do is we shade in the direction that we want here. We want z-scores less than this. Less than is this way, that very little amount. This, by the way, should show me that that's going to be a very small amount. And now let's talk about the table. So from here, once I have my z-score and I have it on here and I have my shading done, I'm going to go to this table right here. This table has a negative side and it has a positive z side. You'll notice in this that my z, it says z right here. These right here are my z-scores, and I'm going to talk about this as well. That relates to your z-scores. Everything in here is area under the curve, which will, since it all adds up to 1, these areas also will end up being percentiles, like what percentile you're in. Because when you add up to 1, that would equal 100%, or in the 100th percentile. You'll notice in the picture that the area is circled to, or is shaded to the left. That's the case for both sides, for both the positive side and the negative side. What that means, huge, huge implications. It means that the areas that you see in this table are only the areas to the left of whatever you've calculated. Right now for this problem, that's what I want. I want the area to the left. But in problems like number 2, we're going to have to do something a little bit different to get the area to the left. So in this one, what I'm going to do is I'm going to go to my table on the negative side, and I'm going to look up a z-score of negative 2.25. The way we do that, I'm going to kind of bring this in a little bit, is I go to here. This is negative 2.2. And what you see up here is that second decimal place. Okay, so negative 2.25, I go over to where it has the 5, negative 2.2, and 5 is here. It's right there. It's a value of 0.0122. So I'm going to write that below it, 0.0122. And what you guys are going to see me do is always put the arrow to the left. It's the area to the left, to the left. That's what I would always say in class. It's always the area to the left. In this one, that's the area that I want. So I actually am going to round that to just 0.01. What that really means is that this value, whatever value this was, is in the 1 percentile, because I moved this like 1%. So it's in the first percentile, which would mean that if I was on a test, I would have scored in the lowest 1% of all test takers. Okay, so let me move to number 2. Number 2. In number 2, you'll see I'm still drawing my curve. That's my first thing. And number 2 is asking for a z-score greater than negative 2.25. So my z-score is still the same. It's still down here, 1, 2, 3. So there's my 3 standard deviations. Negative 2 would be here, so it's less than that. It's like right in here somewhere. So that is a z-score of negative 2.25. But in this one, my shading is not to the left because I want to know what % of people were higher than that, greater than that z-score. Okay. Well, I can tell you that number has not changed. If I go to negative 2.25, it's still going to be that 0.00122. So I still put that 0.0122, but that's my area to the left, to the left. So that's my area to the left. I don't want the area to the left. I want the area to the right. Well, if you think of this, if 1%, if I scored in the first percentile, how many people did better than me? Wouldn't you guys say 99%? Well, that's the math that we're gonna do here. What you do in order to find the area here is you take 1, because the whole density curve adds up to 1. I take 1 and I subtract out that 0.01. You'll see me do this a lot. I round to 2 decimal places because it makes sense to me, especially when I'm putting it into percentages. We would get 0.99, which would mean 99% of people did better than me on this test. Higher than that z-score. Okay. I'm going to skip down now. I will mention one thing briefly. In here it says, do you notice how like these are greater than and equal to, and then this one is greater than with no equal sign? It actually makes no difference in how we calculate it. In this one, and I'm going to go through it quickly, but in this one, to calculate 1.7, so there's 1, 2, 3 standard deviations, right? 1.7 would be up in here somewhere, and they want to know in this one greater than as well. They want to know this percentage up here. So in this problem, in part 3 of this, z equals 1.77. If I were to look at this, the greater than actually makes 0 difference because there are infinite numbers under here of area. There's infinite little values inside here. So saying that it was equal to, like, let's say that that value was 4, it really is insignificant in the scheme of infinite numbers. So we actually don't care about in this context whether it's greater than or equal to or greater than. So just so you guys know, you don't calculate this any different. I still go, except this time on the positive side, I would go to 1.7 and then follow it all the way over to 7, and I get 0.9616. 0.9616. 0.9616 is where that value lands. Again, that's the area to the left. I don't want the area to the left. If this person is at the 96th percentile, I want to know how many are above it. So I'm going to take 1 minus 0.96, and I get 4%. 4% scored higher than that person. That would be the idea behind it. The one I really want to go over is number 4, because you have an area in between. You'll notice my process is the same. You guys are always going to draw these. And in this one, they want to know what % of people are between negative 2.25. So down here, we've already calculated that one, but z-score of negative 2.25, and what people are above or in between there and 1.75. So 1.77 actually, z equals 1.77. So you'll notice that was 1 standard deviation, that's 2, it's closer to 2. So what percentage of people scored in between those two values? Okay, so the way we figure that out, we do the exact same process. I go to the table, I look up negative 2.25. I still have that 0.0122. That's the area to the left. I go to 1.77, which I just did in the previous example. I still have in the table 0.9616. That's the area to the left. And now I want to know this area in between. Well, I know this one at 1.77, that's 96% all the way down. But I don't want all the way down. I want all the way down, but minus this part right here, right? All the way down is 96%, but I want all the way down minus this part. Well, that part we know. It's actually just this 1%. So I'm really taking 96% and I'm subtracting this little piece off right here, which happens to be 1%. So I take 0.96, I subtract my lower number, my lower area, and it will always be that way, and I get 95%. 95% of the values would be 0.95. 95% of the values are between those two values. Go ahead and start practicing some of these. I have my homework help down below if you need help with any of the homework problems.